Welcome back, tech enthusiasts and IT pros, to another episode of Gruber Wired Podcast, where we dissect the hottest trends and coolest technology and occasionally each other's questionable behavior.
And right on cue, John's already trying to go wrong. Thankfully, we've got a hot topic, or should I say a cool topic for you today. We're talking about something that's flipping the script in data centers. Direct liquid and immersion cooling.
That's right. Air cooling, step aside. There's a new sheriff in town, and it's here to keep our servers chill, especially with all these AI and HPC workloads generating insane amounts of heat.
Strap in for the next 30 minutes as we dive into the difference between direct cooling and immersion cooling, why industry giants are pumping billions of dollars into these solutions, and how we at Gruber Communications are leading the charge for a more efficient, sustainable data future.
Stay tuned if you're wondering what servers in a bathtub will look like. You're in the right place.
So, Mark, let's talk about why liquid cooling is such a game changer. Our servers are basically pumping out heat like it's an Arizona July day. AI, HPC, big data workloads, they're melting GPUs if we're not careful.
Exactly. Even those fancy rear door heat exchangers are being pushed to their limits when racks climb above 50 kilowatt hours. And with new chips rolling out at lightning speed, 2 new generations per year in some cases, our conventional air cooling methods are starting to wave the white flag. What do you say about that, Cass?
Yes, absolutely. What's up, everyone? It's good to see you. According to GlobeNewsWire.com, the global data center liquid cooling market is set to skyrocket from $5.65 billion in 2024 to $48.42 billion in 2034. That's a compound annual growth rate, or the CAGR, nearly 24%. If that doesn't sound like a big deal, I don't know what is.
Yeah, I mean, you just see the growth just dramatically taking place and growing. I mean,
I think we have a chart, don't we?
We do have a chart
somewhere.
Anyway, we'll get the chart up here shortly and take a look at that. But you can see over the, since 2024, what the expectations are going into 2034. Isn't that crazy? Pretty dramatic if you actually think about it.
That's pretty significant growth.
Yeah, I know. It's crazy. So, all right, time to get a bit more technical, though. But don't worry, folks. We'll keep it digestible. Cass, break down the difference between direct-to-chip and immersion cooling in layman's terms for us.
For sure. Direct-to-chip, or DLC, you have cold plates attached directly to the processors. A coolant, often mixed with water, mixed with additives, flows through the plates, absorbing heat before it's taken away to be cooled in a heat exchanger. Immersion is completely different. The entire servers or components are submerged in non-conductive fluid like dielectric oil. Heat is absorbed by the fluid and carried away, often with significantly less power needed for fans because you don't really need them.
We did a show previously on this, so if you want to check that out, it's in our library. Yep. But seeing those plates, electronics submerged in liquid was just mind-blowing.
It just doesn't seem comfortable. I mean, it's an uncomfortable situation at first when you're looking at them.
At all. And JetCool.com even notes that direct liquid cooling can support higher power processors and is already proven for 1.5 kilowatt chipsets, meaning immersion cooling is catching up, but some solutions haven't reached the same wattage thresholds just yet.
Mark, I know you read Castrol Dipping Point survey that basically says immersion cooling should be widespread within about 3 years. Is this hype or is this just reality?
It's very real. 76% of data center experts polled said immersion cooling is a must to handle AI and edge computing needs. And get this, 74% 74%.
74%.
Yeah. Said air cooling is reaching the end of its rope. Plus 90% plan to switch to immersion by 2030. Those are huge majorities.
Yeah, they are. That's up there.
That means if you're not at least exploring immersion cooling now, you might be left behind, especially when HPC racks start hitting 50 kilowatts or more. There's talk of racks eventually climbing to 1,000 kilowatts. Air cooling just can't compete with that.
It's mega.
Yeah, that's a lot.
And be sure to drop a comment if you think your data center will adopt immersion or direct cooling, liquid cooling, in the next 2 to 3 years. We'd love to hear your timeline.
Yes, drop your comments as we go through this. A big question we always get, what if there's a leak? Because water near electronics, let's just say that's not everyone's dream scenario.
That's a valid concern. TTK, featured in a recent Data Center Dynamics article, has advanced solutions for both immersion and direct cooling setups. They detect leaks around the tanks, pumps, cool plates, every nook and cranny.
And that's huge because a single leak can bring your entire system operation down. TTK's approach is a pinpoint direction. So you don't just get, hey, there's a leak somewhere. You get, hey, there's a leak at rack 32, section B. Hurry up, get there quick.
But as you guys can see, the TTK is already like working on some wiring. You can see in the video, they've got a whole bunch of neat
this
little
is
tech.
that sensor wire that once it gets and senses that leak, it then sends a signal so you can determine exactly where that leak and pinpoint it so you can get there in a proper amount of time.
That's very cool. Now, sustainability is all the rage, but really it comes down to dollars and cents. And it costs a lot to run those AC units to keep servers cool. Liquid cooling can help reduce overall energy consumption by up to 50% in some cases.
Yeah, that lines up with some of the research from JetCool and others showing the water's higher thermal conductivity and the lower viscosity basically reduced pump power. Some immersion solutions will also let you reuse waste heat, like heating buildings in colder climates.
Hello, free winter heating in. Can someone say Scandinavia? Hey, that's real world synergy right there. Also, Bill Gary at Forbes points out that hardware stays cooler, it lasts longer, less stress, less wear and tear, and lower replacement costs.
One little factoid here, Intel, Microsoft, and Alibaba and other major operators are already piloting or implementing immersion cooling. Are you next? So the Globe Newswire data says the market for liquid cooling in data centers will jump to nearly $48.4 billion by 2034. That's a monstrous jump. We're only in 2025.
That's big. That's a huge jump.
Yeah, with HPC and AI demand surging, plus the 5G and 6G telecom expansions, that it's no wonder. Hyperscale data centers are hungry for more power in smaller footprints. Liquid cooling is basically the enabler for that high density.
And meanwhile, standardization is also happening. Groups like Liquid Cooling Coalition and initiatives with Open Compute Project aim to unify designs, ensuring that we don't end up with 50 different incompatible solutions.
So, pop quiz for the audience. Which do you see being bigger in 5 years? Immersion cooling or direct to chip? Let us know below.
But it's not all sunshine and cool GPUs. Liquid cooling can be pricey up front. Retrofitting an entire data center doesn't come cheap.
No. Plus, you need to manage the fluid. Watch for potential leaks, handle maintenance with specialized training. Immersion cooling can require customized servers or removing fans and other components.
Yeah, that's wild, exactly. But the payback from what we have seen can be substantial in terms of long-term energy savings, space optimization, and extended hardware life. Literally look at some pros and cons or comparison benefits, huh?
Yep.
Yeah. So you can see there's
a lot of
energy savings. That's what pops out to me.
And rack density can increase exponentially.
That's actually huge, right? Because we're talking about overall space, and that's just one of those factors right now. As we grow in this industry, we're losing some of that space, right? Because we need more equipment.
Everything is into consolidation and making it efficient. When we talk about whether we're talking about fiber and how more data going in smaller bundles and things like that.
Correct.
More racks being able to be handled in data centers based on cooling, because there's limitations when it comes to air cooling right now. They can only bring it down so much. So this is...
Yeah, it's true. And then you take a look at these setups and the immersion systems that we have, and they are very condensed in comparison to big, large cabinets, right?
Exactly.
And so as we're able to condense this immersion cooling technology down, it leaves a lot of open space and framework for more of these systems.
It does. And some big names like Submerge, GRC, and Isotope are offering turnkey immersion tanks. That's how real this market is becoming.
Yeah, and some companies like JetCool.
You wanted to say JetBlue, didn't you?
Yeah, I don't know what. My brain is all.
We're going to have some flying data centers.
Yeah, it's a lot of information, but not saying that it's not cool.
No pun
information,
intended, huh?
Pun very intended. But it's crazy. So JetCool debuted their 300 kilowatt coolant distribution unit, or their CDU, aiming to scale up to 1.2 megawatt for hyperscale AI workloads, which is no small feat.
I know. You see these success stories, and then you realize for like HPC or AI training farms, immersion might just be an option. It might be the only feasible route for you to go.
Right. So...
Look at that. I love that. Watching that being, immersed down in there. It's just kind of cool to watch that, right?
Yeah.
The technology itself is amazing.
I remember Harry telling me that for the first time, and I Googled it and I watched it, and I'm like, you got to be joking.
Well, it just goes against your brain, kind of plays around there, because we're like, hey, you can't put electrics into fluid. It just doesn't work. But it does. It's the type of fluid, right?
Right.
And that's what we're talking about, dielectrics.
So let's say someone wants to dip their toe, pun intended, into immersion or direct liquid cooling. Where do they start?
Well, I'm glad you asked. First, you should do an assessment. So check your rack densities, existing cooling infrastructure, and future demands. The second thing you should do is choosing the fluid. So for immersion, you want a dielectric so it won't degrade your hardware. For DLC, you want to ensure that you have the right water or glycol mix. Third thing you should do is leak detection. So invest in something like TTK's system, like we saw before, right? It's got the wires around their cooling systems, and it will tell you exactly where you have a leak. Prevention is worth $1 million repair.
Yeah.
Or the last thing that you should really look into is the supplier partnerships. So work with proven vendors, people that you trust, people that you know. This is not a place to cut corners.
Yeah, and here at Gruber Communications, we want to partner with clients as they embark on this journey and then be able to supply them with long-lasting cables that can handle the dielectric fluid environments that they're going to be encased in.
And if you want a deep dive, pun also intended, on your data center's cooling needs, shoot us a message at Gruber Communications. We'd love to solve the big heating problems.
So in the next 5 years, do we see every new build going with some form of liquid cooling?
I'm thinking so.
Yeah, probably. I mean, AI workloads have grown exponentially. Like, there's a whole bunch of different AI places that you can go to ask them questions like ChatGPT or Grok to make images, right? The Casual survey suggests that by 2027, immersion might be the dominant data center cooling technology.
Sure, and regulatory pressure to reduce carbon footprints is also forcing data centers to be more energy efficient. Liquid cooling is a direct path to slashing PUE, power usage effectiveness.
And the sweet spot is still being discovered. Maybe a combination of direct-to-chip for certain racks and immersion for HPC racks. It's not a one-size-fits-all, but the future is definitely fluid. Pun absolutely intended.
So, fun fact, Google has tested liquid cooling for its TPU pod since 2018.
Oh, wow.
Wow.
Yeah, we asked our social media followers out there for their top questions. One question that came in, are these dielectric fluids safe for the environment?
Well, that depends on the fluid. Some of the older formulas are less safe, but any of the newer ones are more eco-friendly, biodegradable, or synthetic with lower environmental impact.
Next question, can I use liquid cooling in a small facility? Absolutely, but watch out for weight limits on floors if you're doing immersion tanks. DLC might be simpler for smaller retrofits.
So, if you got a burning question, comment or DM us on Twitter, aka X, at GruberComms, or on LinkedIn.
If all this talk about liquid cooling has your gears turning, Gruber Communications is here to help. Whether you're big, small, or somewhat in between, we've got data communication solutions tailored for you.
We want to keep pushing the boundaries in data center communication and innovation. So if you're ready to optimize, slash energy bills, and future-proof your AI and HPC investments, we'd love to chat.
And if you just want to geek out about the newest HPC GPU or the high performance computing graphic processing unit release, I'm always up for that too. You just got to bring your own coffee.
Well, how about we bring some water? I'm kind of thirsty right now. I got to take a bit of a drink here. So anyway, Cash, you just brought up something that we haven't talked about much, and that's the high performance computing graphic processing unit, right?
Yep.
So what exactly is that? I mean, in the layman's terms.
The high performance GPUs and graphics processing units.
Yeah.
Those would be the ones that perform at a high level.
The ones at the high level.
Well, Jesse was kind of explaining it a little bit earlier, but
Yeah.
I'm not as well versed as he is.
Those are like all those NVIDIA chips, right? And all the new sets that they're bringing up. And
Yeah.
yeah. They're the what?
They're in the ChatGPT data
H100s?
centers.
H200s.
Okay.
NH100.
So it's just much more processing power,
NH200.
right? We're
Yeah,
talking about
yeah.
just the processing power, but unfortunately, along with seeing that processing power comes more generation of heat.
Right.
Right. And so that's why we get into dielectric fluids. We can actually look at this immersion cooling.
Right. And dielectric means it does not conduct electricity.
Correct.
Which is why this stuff can be immersed in it, because it doesn't.
It's
arc.
non-conductive. Yeah.
Yeah.
Yeah. It's pretty amazing stuff, this
Who
technology.
knew? Who'd have thunk it?
I wouldn't thunk
Right?
it. And again, when we watch those videos, if you can bring the video up of them submerging it again, it just doesn't compute in my brain, at first when you see this, because anytime you're taking electronics, putting it in, any sort of liquid, it just doesn't feel right.
Right. Exactly. And is it there? No.
yeah,
it's
you
not
see, it's this whole
There it
container. There it
is.
is, right
Yeah.
in there. It's just like
cool.
you guys said, it's so weird.
It's not
seeing
AI
it.
either. Yeah.
Right.
No.
I've seen a couple of PC builds that have liquid cooling in it, but it wasn't immersed like this. It was more of that
Doesn't that just
direct to
blow
chip
your
type
mind?
stuff.
It blows my mind.
Yeah, it's crazy.
It goes
Yeah.
against everything you think should be working.
In my
right?
head, it looks like they're going to be electrocuted, but they're not.
And from the projects we've worked on, I know we talked about this before on the show, but we do have solutions for the cabling for this dielectric fluid.
Right.
And I actually think now that we actually have a working model where we have implemented some of our cabling into this dielectric fluid now for over a year with the customer.
Right.
And the cables still appear to be working well and haven't had any issues with them.
Right.
You
And
know,
the
they're not breaking
problem
down.
So the challenge is that there are a few few different types of liquids that can be used in immersion cooling. Some are ether based, and the type of liquid and how it reacts with like the rubber or plastic in the cable can material from the cable, which means draw out chemicals from the cable, or which will make it brittle, or it can actually absorb the dielectric fluid and make it expand and create pressure on the inside wires. So there's a lot of work that's been done to determine the type of dielectric fluids, because
all the equipment,
right?
I mean,
right. There's a lot of stuff on the motherboard
correct,
that needs to be considered as well, along with the assemblies. So it's something that one of our customers was having to replace these cables once every month and a half, 2 months.
About every 2 months. Yeah,
right. So we've been down now for almost a year, right? And talking about it, and that's why we had another podcast on it before. Because seriously, it's still, this is the Wild West when it comes to leading technology, and there's a lot of research that's been done, but still needs to happen. And then there's just practice in the field. Sometimes, testing things out and proving things out has to come in the open environment.
People need to realize when you dive into this scenario of immersion cooling that we are still working in that kind of that rough neighborhood, right?
Yeah.
I mean, just in generalization, you just can't take any cable and put it into this. It's still a harsh environment scenario.
Right.
So having the right type of materials for that job is really important. With this, you get the right type of cabling with the right type of jacket for the dielectric materials that you're using, because there are different dielectric materials out there on the market.
Right.
So it might not be as one size fits all. You may have to scale your work accordingly, for the job at hand.
Right. Well, yeah, I'm drawing a blank right now, but there's like 3 or 4 different types of dielectric fluids that have their bases. So like I was saying, like the ester base or ether based, polyfluorocarbon based, and how they work and how they react. So there are actually open source documents that have done material studies on the different types and bases of fluids that we have. We've used these documents to determine whether polyurethane or TPE, what types of jacketing materials are going to work.
Yeah, because you don't want leaching.
No, no, and it depends on what fluids you're using. So we've done the research and we've looked at it, and we know we have the reference materials on studies that have been done by huge companies, oil companies, major oil companies, but there's a consortium of businesses that have gone together to actually pioneer computing in this field, so that materials that are used will stand up.
Yeah, and there's like you said, there's plenty of research. So make sure you do your research, do your homework, so you know what direction you're heading. Because there's a few different options here that you can take in implementing this type of system.
Exactly.
But make sure that you take the proper option for yourself and what you're looking to do and accomplish.
Right.
We're going to see this growth in data centers. I think just extreme.
Exactly.
Just because of the heating factor.
So when you're probably going to be working with a professional company putting these together, insist on Gruber as your cable provider. We'll work with you. We'll help them, outfit your unit, your rigs with cables that will endure through the long term. And these are, nothing is going to last forever in these environments. These are new environments, and we're still creating new cable types. So eventually, hopefully, somebody who was talking to me was actually an engineer overseas that I was speaking with about eventually considering using Teflon as a material for these cables. So
that's interesting.
Yeah,
I could see that. And now here's the thing. we're seeing this growth in this industry come about, and I think a lot because, and it goes back to AI. AI is just pushing everything, right? Well, as AI advances, the need for more of this computing capability, the heat rises. Yep. So
the heat is on.
The heat is on, and as these advancements take place, we're going to see the advancement in the equipment itself. I mean, we always talk about AI and what it's doing, but we never go back to talk about the equipment that's needed to support the AI background.
Right. Everything is hand in glove.
Yeah.
Right.
Yeah, for sure.
Yeah.
It's crazy. I like this video. Is this airing right now? Yeah.
And while this is going, we have a comment from
Okay.
Major Tom on YouTube.
Okay.
Oh boy.
He said, "Did John get taller?" And also, great subject.
Did John
No,
get
I don't think I
taller?
got taller. I'll take that as a compliment. Thank you, Major Tom. I'm not sure if I'm supposed to take that as a compliment or not coming from that guy.
And moving
Who
on.
knows?
You guys want to see the DLC?
The
The
DLC.
direct to chip
There you go.
liquid cooling. Give me one
From
moment.
Isotope. So these are really super cool because, they're not immersed in a tank. These are actually removable units that are put together, and they're sealed. So everything is encased internally, and they go direct to chip. So you can see that the dielectric fluid is actually operating inside a single box.
So in
They can be
case there's
moved and
the fluid and it's being pumped into, or is it just flowing naturally through?
Well, I think direct to chip means that there is on motherboards how there's always been like heat sinks on the chips. Well, that's kind of direct to chip, except that before you had fans blowing on the heat sink.
Correct,
Right,
yeah.
to disperse, and now you have liquid flowing over those heat sinks instead to remove the heat.
Gotcha. Okay. That's pretty cool.
Yeah.
So all these different alternatives coming into play.
Yes.
And that's going to be great. I mean, more options we have, the better off our systems could be to choose for our particular needs.
Exactly. And there will be a VHS or Betamax will win out, right? Eventually, right? So there will be a clear winner at some point, but the options and I, like you had said earlier, I think it's important that the industry not have 50 different standards. That it
Correct.
really comes down to best practices, and that way cost efficiencies go up, because if things are going in a certain direction, then it makes it easier to replicate it.
Yeah.
And experts, you don't have to have like siloed experts that are specialists in one particular thing. It kind of drives everything to a center lane.
Yeah, and it
Which
makes
I'm
everything,
totally in
as
favor
it
of.
comes together, it does make everything more economical.
Yep.
So all I can say is, here we are. Thank you for joining us in this deep dive. Yeah, I can't resist that pun, right? Into direct liquid and immersion cooling. Remember, the data center landscape is changing faster than I can say dielectric fluid. Don't get left behind with overpaying to cool your servers.
That's right. And we just ask you to like, subscribe, and share this channel. Follow us on social, and let us know which cooling solution you're going to place your bets on. Air conditioning is a fading legacy solution. Liquid is the wave of the future.
No pun intended, right?
No.
But for now, stay cool, stay curious, and thanks for watching the Gruber Communications Podcast.